Hello good people, I'm going to summarize the intermolecular forces. There are a lot of terms that are being used somewhat interchangeably. Electrostatic force, intermolecular force, van der Waals force, London dispersion force. Earlier I stated that you can think of them as boxes within boxes. So let's see if I can use that analogy. I'm going to start with a hydrogen bond. Recall that a hydrogen bond is a bond that occurs between two polar molecules, where one has a partially positively charged hydrogen, the other has a partially negatively charged nitrogen, oxygen, or fluorine. A hydrogen bond is also a type of dipole-dipole interaction. These interactions occur between polar molecules. The dipole-dipole interactions are part of van der Waals forces, and these involve covalent molecules. Van der Waals forces are a subset of intermolecular forces. These involve all molecules. Finally, intermolecular forces are a subset of the electrostatic force. And now, starting with a very specific hydrogen bond, I could go to a more general definition. I could say that a hydrogen bond is a type of dipole-dipole interaction, which is a type of van der Waals force, which is a type of intermolecular force, which is a type of electrostatic force. Boxes within boxes. When it comes to van der Waals forces, dipole-dipole interactions are not the only game in town. There is a subset of London forces. And here we can have dipole-induced dipole interactions, which occur between a polar and a non-polar molecule. The polar molecule induces a temporary dipole in the non-polar molecule. We also have dispersion forces. These occur between non-polar molecules and are a result of the random movement of electrons, where one side of the molecule suddenly ends up with the most of electrons and therefore becomes partially negative, while the side without the electrons becomes partially positive. To round off the intermolecular forces, we also have the ion-dipole interactions. These are interactions that occur between ions and dipoles. Note that they are not considered van der Waals forces, but they are an intermolecular force. Finally, I would like to briefly mention the relative strengths of these intermolecular forces. So let me slide a little bit to the right, like so, and have a look at this diagram. The weakest force is the dispersion force. Then we have the dipole-induced dipole, then dipole-dipole interactions, hydrogen bonds, and at the top, ion-dipole attractions. That is all for now, and I will see you on the flip side.